Hello and welcome back. Let us try to understand what is normal distribution. This binomial distribution, normal distribution, these are all theoretical distributions. When I say theoretical distributions, in theory, data will be distributed like this. Why do you need theoretical distributions? Generally, human beings need an ideal personality or ideal object to compare with. So to understand these kinds of things, you need some theoretical distributions. So if your experiment's outcome is real valued, then you can use the normal distribution to understand the data and its behavior. If it is discrete, then you can use the binomial distribution to understand its behavior. So the probability density function for normal distribution is this one. Here mu and sigma are the mean and standard deviation. So there are, when I say normal distribution, there are many different normal distributions. Depending on mean and standard deviation, the curve's shape will change. But as a whole, they form a bell curve. So we'll understand what exactly this bell curve and how they form bell curve with an example in a moment. But let me try to explain a little bit of theory. So if you have zero mean and one standard deviation, that is called as standard normal distribution. If a particular data's probability distribution has got zero mean and one standard deviation, you call that as standard normal distribution. Here I am showing four kinds of normal distributions. The diagram was picked up from Wikipedia, and I am showing you four kinds of normal distributions here. For three normal distributions, the mean is 0. See that the center of this red curve and the blue curve and the yellow curve are 0. But for the green curve, the mean is -2. So it actually deviated a little bit to the left side. And then the standard deviations are the variances we are showing here. The standard deviation means square root of whatever 0.2 and 1 and whatever, right? So when a data is normally distributed, it can have any of these shapes, but ultimately the shape should be the probability distribution should be forming a bell curve. Normal distribution will form bell curve, but depending on the variance, the bell curve's shape will be decided. If the spread is more, the variance is more, it's going to be slant, like the yellow distribution. If the spread is a little less, it's going to be like red one, it's a little steep. If the spread is even less, right, it's going to be like the blue one. See this, the variance here for the blue curve is 0.2, the variance for the red curve is 0.1, and the variance for the yellow curve is 5. The variance is growing, the spread is growing, the bell curve shape is actually becoming slanter and slanter. So bell curve can be a little slant or a little steep, that doesn't matter. So that is an introduction to the normal distribution. Let us try to take an example and understand. But before that, we need to understand what is the use of normal distribution. When data is forming a bell curve, there is a norm that 68% of the data is going to be within one standard deviation. When I say within one standard deviation, the mean minus one standard deviation and mean plus standard deviation, there will be two numbers, and 68% of your data which is forming bell curve will be lying in between those two numbers, and 95% of the data is going to be within two standard deviations. That means if you subtract 2 into standard deviation from mean and add 2 into standard deviation to the mean, those two numbers will be the boundaries of 95% of your data which is forming bell curve. And 99.7%, the most of the data is going to be between 3 standard deviations, mean minus 3 into standard deviation and mean plus 3 into standard deviation. So we'll understand all this theory with an example. Let us jump in and understand. So I have taken a company where there are 32 employees with employee IDs, different designations, and the experience levels and salaries. And the salaries of this company are normally distributed. What is normally distributed? When I actually did a histogram, it actually formed a bell curve. If you see, if you connect all these tips, it is forming a bell curve. So I can say the employee salaries data is normally distributed. What is the advantage or what is the use of having a data set like this or the data like this? I said, the 68% of the data is going to be within one standard deviation, right? So out of all the 32 employees, if you try to see, 68% of the employees, around 20 people, salary is going to be within one standard deviation. One standard deviation means mean minus standard deviation. What is standard deviation here? 17,139 is the standard deviation, and mean is 54,735. That means the mean salary of the 32 employees is 54,734. The standard deviation of the 32 employees is 17,139. What is standard deviation? Average squared distance from mean, square root of the average square distance from mean. You can actually say the average distance. When you pick a person's salary, on an average, the salary will be 17,139 far from mean. That's the standard deviation's meaning. So if you add 17,139 to mean or subtract 17,139 from mean, that's the kind of average salary, or that's the kind of range in which most of the people will fall, or most of the people's salaries will fall. So here within one standard deviation we are saying 68%, because when data or the probability distribution is forming normal, like a normal distribution or forming a bell curve, we can say that 68% of the data is going to be within one standard deviation. So 95% of the data is going to be within two standard deviations, and 99.7% of the data is going to be within three standard deviations. Let us jump back and try to understand this with code. So here I have taken the data set, the employee data set, and then the salaries, the experiences and salaries are like this. And then we are trying to plot a histogram here, because if you take the salaries and look at the salaries, there are different numbers there. If you try to take each salary as a category, even though they are countable, each salary as a category, and try to do a bar chart, you will get a chart with equal height bars. So you should definitely take ranges there. So when you take range of values on x-axis, you call that as histogram. When you take categories on x-axis, you call that as bar chart. So here I have taken ranges like 0 to 10,000, 10,000 to 20,000, 20,000 to 30,000, and trying to see how the distribution is, how the data's distribution is. So here I have specified that ticks, which is nothing but how much scale you should have on x-axis and how much scale you should have on y-axis. And then I have chosen 7 bins, because there are 7 ranges from 20,000. The minimum salary here in this data set is 20,000 and maximum salary is now 90,000. There are 7 bins are there, so I have taken 7 bins there. So it is forming a bell curve, and now I calculated mean and I calculated standard deviation. As I have explained before, the standard deviation is the average distance from mean to any data point. Average distance. When I say average distance, it is an approximate distance. When you take any random person's salary from the dataset, it will be 17,139 far from mean. It is an approximation. Statistics is all about approximation. Okay. So let us see what is 68% and see whether the rule 68, 95 and 99.7 rule holds true or not. So I have tried to calculate 68% of 32. That is 32 number of employees are there. So there are 21.76 employees. So if you calculate the mean plus standard deviation and mean minus standard deviation, in this range there must be 21 employees, because the normal distribution is saying that when data is forming a bell curve, 68% of the data should be between or will be between mean minus standard deviation and mean plus standard deviation. Let us see that. So I have calculated. So 71,875 and 37,596. Let us filter the data on salary. So I have filtered the data. To filter the data, I have added the conditions. So the salary greater than 37,596 and salary less than 71,875. The number of records should be equal to or approximately close to 21. Let us see. So we have got 20 records there. That means this rule is holding true. 68% rule is holding true, because the salary data is forming a bell curve. 68% of the data is within one standard deviation. Let us see the same thing for the 95% rule. What is 95% of 32? Is 30 people. Around 30 people are the 95% of the 32 people. So let us see, if I calculate mean plus 2 standard deviations, 2 into standard deviation, and mean minus 2 standard deviations. So these are two numbers, or two salaries, or salary ranges. When I try to see or filter the data set, there should be around 30 people falling in this range, because the salary data is forming normal distribution or bell curve. Let us, I have filtered it and tried to see, there are 30 people, exactly 30 people came in as 90 into the 95% range. So within 2 standard deviations, 95% of the salaries of the people are there. So the normal distribution is holding true. Whatever the rules it is specified is holding true. If I say 99.7%, most of the people, 32 people, should be falling within 3 standard deviations. So I have calculated the mean plus standard deviation, 3 into standard deviation, and mean minus 3 into standard deviation. So I have got 32 people. So it is actually falling. The range is actually a bit more than the minimum and maximum also, but it is actually satisfying. So when data is normally distributed, or when data is forming a bell curve, you know the mean and standard deviation. You know that how many people are falling within a salary range, how many people are falling within 68% salary range, and within 95% and within total number of people. So if you know this kind of data, when you are trying to give hikes to the employees, you can plan accordingly. Here I have got only 32 people. Suppose that a company like Infosys, where you have got lakhs of people, maybe 1 lakh or 1.5 lakhs, or 100,000 or 150,000 number of employees are there, you definitely need to form a bell curve and understand the salary distribution, and then accordingly you can plan how much percentage of hike you should be giving for the 68% of the people, and maybe the first half of the people, like from 20,000 to 37,000 and 70,000 to the low level say employees and the high level employees, and accordingly the budget can be estimated. So when the salaries are forming a bell curve, it is easier for us to understand and then plan accordingly. That is the use of these theoretical distributions. We use normal distribution a lot in our course and real time also. So when data is forming a normal distribution or bell curve, there are some conditions hold true. The distributions are symmetric around mean. That means lots of people's, most of the people's data is close to mean, and then mean, median, mode are going to be same on a normally distributed data set. And the third thing is the area under the curve is going to be 1. What is the curve? If you look at it, the normal distribution curve here, the area under this blue curve or red curve or yellow curve or green curve, any data set which is forming a bell curve is going to be 1. So we will use all these rules and try to do some math also, but let us try to understand theoretically. And the fourth rule is that normal distribution is denser in the center and less denser at the tails. If you see this as the normal distribution, at the tails the data is going to be less dense, and in the middle the data is going to be dense. The bar heights are going to be small. Normal distributions are defined by 2 parameters, mean and standard deviation. So these are all the important concepts about normal distribution. And when your data is forming a bell curve, and if you know mean and standard deviation, you can understand data's patterns and then accordingly make decisions. That's the use of normal distribution or any theoretical distribution. Thank you.